It's so loud. Okay, so we're gonna start chapter 4 today. And it is mainly about inequalities. And so I know that last year with in pre-algebra, you guys did some of this already. So I believe these first 3 lessons are going to be review, and that is why we're doing the 3 together. I did shorten the homework on each of the lessons. So that should help alleviate the stress about having 3 lessons on one day. All right, so this first section right here is just, we're gonna read some of these out and write what they mean. Most of you will probably already know this, but this x equals 3, that's a given, right? This one, when you have a slash through the equal sign, x does not equal 3. This one is x is less than 3. Oops. And then x is greater than 3. Okay. Now we get down to this, where you have an equal part of an equal sign underneath your inequality. That means that it can be equal to 3. So in this case, x is less than 3, less than or equal to 3. And then this one is x is greater than or equal to 3. Okay. Now, one thing that I want to show you really quick is that these are not the only ways that you can write this. You could also write this where your x is on the other side. So if I wanted to say that x is less than 3, I could write it like this. You always want to read it from the variable's perspective. Okay, so you always want to start with your variable. Start with x, don't start with 3. I mean, you could say 3 is greater than x, but when you go to graph it, that's a little bit confusing. So start with x, and because of the position of your inequality, x is less than 3. I could also write this, and that's telling me that x is greater than 3. Okay. This way, x is less than or equal to 3. X is greater than or equal to 3. So don't let that confuse you. Now, what some students do is if they end up with an answer where the number is on the left side, they'll sometimes rewrite it so that it's on the right side, and that because that tends to be easier for some to read. All right, let's go down to this next part. Do you guys remember graphing in pre-algebra, graphing inequalities with open and closed circles and the direction of your arrows and all that? Okay. So anytime that you have a less than or greater than symbol without the equal sign, you will always have an open circle. And an open circle just is not filled in, basically. Anytime you have an equal sign at the bottom, you will have a closed circle. A closed circle is just filled in. Okay. If your answer is less than, then your arrow is going to go in the less than direction, which is to the left. If your variable is greater than, it will go in the greater than direction or to the right. So this right here, if I were to put an x for every one of these, put an x right in front of every inequality. Okay. What this is saying is that x is greater than, so greater. Because there is not an equal sign underneath it, you're going to have an open circle, and your arrow will go to the right because it's greater than. Here, X is less than. So you have an open circle because there's no equal sign below it, and it will go to the left. That's the less than direction on a number line. So if that's a little bit confusing, if I had a number line right here, imagine that I had a -5 here, 0, and a +5. Okay, this right here is less. And this over here is greater. Okay. Here we have X is greater or equal to, right? So because it has that equal sign, I have a closed circle, and because it's greater, it's going to go to the right. Here we have less and equal or equal. So it's a closed circle because we have the equal sign, and it's going to go to the left. Okay. So these are just some other examples of what the inequalities will look like. And we're going to go ahead and go to the next page and start graphing some of these. Okay. So let's look at example 1. Example 1 has X is greater than -3. So what we're going to do on this is we're going to put a circle above -3. Is it going to be open or closed? Open, because there's no equal sign. So above -3, you're going to put an open circle. And then you have to decide, is your arrow going to go to the left or the right based on the inequality symbol? So if X is greater, then our line has to go to the right because that's the greater than direction. Okay. And that's pretty much all you're doing on this whole page. You do get down to some duplicate, or not duplicate, but where you have 2 inequalities that you have to graph. Okay, so let's look at this next one. We have X is less than 5, so I'm going to put a circle above 5. Open or closed? Open, so open above 5. And because it is less than, I'm going to go to the left. All right, example 3, go ahead and try example 3. Okay, for example 3, you should have a closed circle above 2 because it has that equal sign below it. And then since X is greater than -2, I'm going to the left. Now, what these arrows are saying is that X can be any number that is -2 or bigger. It could be -2.2. It could be 17.5. It could be 1,000. It can be any number beyond that -2. Now look at number example 2 really quick. Because that is an open circle, if you were just to look at the graph, you would say, okay, X can be anything less than 5, but it does not include 5. Okay, so 5 is not a solution with an open circle, but down here, -2 is a solution because it's a closed circle. All right. Okay, look at number 4. That one's a little bit different. What is the absolute value of -4? 4. So really what we're graphing is X is less than or equal to 4. Okay, so go ahead and graph that. And then check your answer when you're done. All right. Now we're looking at number 5. Number 5 is weird. Basically, it says X is not equal to 1. That means X could be any number except 1. So does anyone have any idea how we would graph this? Open circle above 1, yes. Yes, arrows going in both directions. Good. Okay, example 6, we're gonna graph both of them separately. So here we have x is greater than 6, so everyone graph that one. And then graph x is less than 2. And this is what you should have gotten. Now, later on, what we're going to do is we're going to be solving inequalities. And there is a type of inequality called a compound inequality, and you will be graphing them just like this. Okay. What I would like for you to do now is I want you to graph the rest of these 7 through 10 on your own, and then we're going to check them in a minute. Okay, so go ahead and work on those. Okay, go ahead and check your answers. Make sure what you're making sure is that your circles are either closed or open, and then the direction of each arrow. Okay. Okay, any questions on these? All right, let's go ahead and go to page 3. We're going to now practice writing inequalities. So whenever I write inequalities, there is a fast way that I do it, but I'm just going to go over the first 2 before I show you that way. So if you look at number 11, I know that I'm going to have x is something then -1. So I put my x and my -1. Now I'm trying to figure out, is it greater than or less than? Oops, my screen froze. Hold on just a second. So now I need to decide if it's greater than or less than. And so look at your arrow. Is it going to be greater than or less than? It's greater than, because it's going in the greater than direction. Is it also equal to? No, it's not, because it's not a closed circle. Okay. So then go to the next one. I know I'm going to have x is something, then let's see, -4, -5, -6. I don't know. That's probably -7. Okay. And this time my arrow is going to the left. So it's going to be less than. So x is less than. Let's look at 13. I have x, and then I have 25. Since it's a closed circle, I know I'm going to have an equal. And since it's going to the right, I know that it's going to be greater than. Okay. So are there any questions on how to do those? Okay, I want you to go ahead and finish those, and then we'll check them in just a minute. Okay, go ahead and check your answers when you're ready. Okay, let's go ahead and move on to page 4. All right, on page 4, you're given an inequality. And the thing, an actual, well, I can't say equation because it's not an equation. And they're wanting to know if the values -2, 0, 2, or 5 are a solution to the inequality. And there's 2 ways you could do this. You can plug the numbers into this equation to see if the left side matches the right side, or it makes it true or false. Or you could solve the inequality for x and do it that way. Now, we have not really gone over solving inequalities, but I'm going to show you both ways. So if one way is better, there's one way that's faster. Okay, so I'm going to show you the longer way first, though. Okay, so basically what you're going to do is you're going to write out this inequality, and you're going to substitute -2 where the x is. So we have 2 here times the -2. Okay. We're going to add 3 because that's what the equation tells us to do. And then it says it's greater than 7. Okay, so now let's solve this. 2 times -2 is 4. 4 plus 3 is 7. So 7 is a solution, or I'm sorry, -2 is a solution here. So I'm just gonna underline that so I remember.
It would be 2 times -2 is -4.
Oh, I'm so sorry. Okay, yep, you guys are right. Hold on, let's go back. Let's go back. And thank you. -4. There we go. Okay, -4 plus 3 is a -1. Is -1 greater than 7? No, so that is not a solution. We're going to do the same thing for 0. So we have 2 times 0 plus 3 is greater than or equal to 7. Okay, we're going to do the same thing.
Are we going to do the same thing for everyone?
Yeah. So then 2 times 0 is 0. 0 plus 3 is 3, and 3 is not greater than or equal to 7. So this is not a solution either. 0 is not a solution. Okay, let's go ahead and do the same thing for the next two numbers. Okay, so 2, you should have gotten a solution for 2. And 5. Okay, so the answer, or it could be equal to.
Okay.
Yeah, in this case. So our answer is 2 and 5. Those are solutions to that equation. Okay. Now, what I want you to do is just watch me solve this a different way, and then you're going to choose which way you want to solve these from this point on. So I'm going to take 2x plus 3 is greater than or equal to 7, and I'm going to rearrange it and solve it for x. Okay, so I have to subtract 3 first, and I get 2x is greater than or equal to 4, right? And then I divide both sides by 2, and I get x is greater than 2. Oh, equal to, greater than or equal to 2. So what this is telling me is that any value that is greater than or equal to 2 is going to be a solution. So this is not greater than or equal to 2. 0 is not greater than or equal to 2. 2 is equal to 2, and 5 is greater than 2. So 2 and 5 are my solution.
So it has to be greater than 2.
Exactly. So there's two ways to do these problems. You could do this the quick way, or you could do it the longer way. And I will tell you, if you can learn to do it the quick way, I think that's lesson 4 or 5. And you'll be well on your way to being able to solve inequalities like this. It's a 2-step inequality. Okay, so can I ask how many of you will be doing it this way right here? Okay, all right. So let's go ahead and do example 20, and I want you to try to rearrange it and solve it for x, since that's what you're all going to do. And then we'll find a solution for that. Okay. Oh. Do you guys know the rule about dividing inequalities by a negative? What is it, David? Yeah, the inequality symbol. So anytime you divide by a negative, it flips this sign. So our answer is actually x is less than -2.
Wait, in the 1.2. Changes to. That was multiplication.
Multiplication and division, yes. Okay. So if x is any number less than -2, it can't be -2, but it's less than -2. What are our solutions? Out of those four, which one could be our solution? Yeah, just -3.
Oh, minus 2.
-2 is equal to -2.
Should
Oh, it has.
greater
Yeah, it has to be less than.
greater than or like this. It's greater than we. Look at this.
So this is less than. There's no equal to, so it has to be less than -2, and -3 is the only number up here that is less than -2.
So it can only be equal to that, the thing.
Right, exactly. Okay, I want you all to try number 21. On your own. Okay, go ahead and check your answer for number 21. Okay, let's go ahead and move on to word problems. Yay. I threw that with sarcasm. All right. Here are some keywords and to be able to translate inequalities. The most confusing ones that I notice are at most and at most is one, and at least. And those are the at most means that it can't be more than, so it has to be less than. At least means that that's the minimum it could be, so it can be greater than that. So I would say that anytime you're reading some word problems and they have those terms, maybe refer to this chart until you get the hang of it. So let's go ahead and look at example 22. We need, actually this should say inequality, not equation, but it says 3 times a number added to 2 is less than 15. So let's look at this. 3 times a number added to 2 is less than 15. So it's written right in the words. Okay, so let's write that down here. We have 3n plus 2 is less than 15. Then it says, is 5 a possible solution? Well, we're going to plug 5 into the x and see if it's a possible solution. So we have 3 times 5 plus 2 is less than 15. And we solve. Is 17 less than 15? No. So 5 is not a possible solution. So we just put no. Okay, let's go to 23. 23, you see these a lot in our word problems. The sum of 2 consecutive integers is greater than 30. So I know that I'm going to be adding. I know that it's going to be greater than 30. 2 consecutive means one right after another. So you have one number and you're going to add that to the next number, but we don't know what the first number is. So it's x plus 1 because you're going to add it to the first number. You're just going to add 1 to that first number. So this would be your equation whenever you come up with like adding 2 consecutive numbers. So we have x plus 1 is greater than 30. And then it asks, is 15 one of those numbers? So we could just plug 15 in.
Both places, so they.
Right. So 15 plus 15 plus 1 greater than 30. (31) is greater than 30, so then the solution is this. And I did choose word problems that are similar to the ones in your homework. So.
I started seeing the radar.
Right, because it wants a number that's greater than 30, and so since 31 is greater than 30, then the answer would be yes. Okay, let's go to 24. You have an equal number of quarters and dimes, and the total amount you have is less than $3. Okay, so I know that I'm gonna have an equation that is less than $3, okay? And it says I have an equal number of quarters, and I have an equal number of dimes. So quarters value at 0.25, so 0.25x. And then since my dimes are the same number, I can use x for my dimes. Okay. Do you guys know, like, do you know what I would do to this to make it easier to solve?
Use over it.
Or times it by 100.
Yeah, I would times it by 100. So that's what I'm gonna do here. Move this whole thing by 100. And you get. Okay, and now you just solve it for x. Oh, okay, and then it says, can you have a total of 8 dimes? So I'm just gonna, I should have plugged in 8, but I didn't. So now I'm just gonna plug the 8 in here and solve. And see if that is less than 300. Okay, so 35 times 8. So I get, yep, 280 is less than 300. So we have yes. Last problem for 4.1. Okay, so this one I have to write some stuff out. It says that one angle is 25 more than another angle, and the sum of their angles is equal to or less than 70. So we know that the angles are going to be equal to or less than 70, okay? But now I have to figure out this other part. One angle is 25 more than another angle. So we have two angles here. Angle 1, I'm just going to name A. Angle 2 is 25 more than this one. So A plus 25. Okay. And then their sum is less than or equal to 70. Do you guys remember this from the previous word problems we had in equations? It's very similar to that. So our equation is A plus 25. If you put 2A plus 25, that's also correct. Okay, so now it says, could the smaller angle be 20? Well, let's figure it out. We have 2A plus 25. And we're going to plug 20 into there. See if that is less than or equal to 70. Oh, I put in the wrong. Oh, no, that's right. Oh, here I put is 15 a solution, but that should be, that should say 20, not 15. I need to change that. I don't know. You guys want to cross that off and put 20. So can 20 be a solution? Yes, it can, because it's less than. All right. So that is the end of 4.1.